Good day, welcome to the third part. Dito sa continuation ng ating pipe refresher. So last part, ang ating diniscuss is hanggang number 33 for gas turbine power plant or the Brighton cycle. So this time, we're going to discuss another or continuation starting at number 34 for another type of power plants. Alright, so let us discuss. Number 34, a 650 brake horsepower diesel engine uses fuel oil of 28 degree API gravity at 45 degrees Celsius. Fuel consumption is 0.56 pounds per brake horsepower hour. Cost of fuel is 7.95 pesos per liter. What is the density of the fuel used in kilograms per liter? So ito ay parang kasama lang din ng sa topic ng fuels and combustion. Alright? So dito ang hinahanap ay density ng fuel. So we all know na makukuha natin yung density ng fuel based on its specific gravity. So i-multiply lang natin yan dun sa density ng water at the same temperature dun sa fuel na ginamit dito sa problem nito. Alright? So, pwede naman natin gamitin yung constant na density of water in SI unit. So, nagre-range naman siya into various temperature or in certain temperature. Alright? So, pwede pa rin natin siyang gamitin for the temperature given for this problem. So, first one, hanapin muna natin yung specific gravity ng fuel na to at its specific na temperature which is at 45 degrees Celsius. So, una, makukuha natin is yung specific gravity niya based on its degree API. So, we have again the formula of degree API as equal to 141.5 over the SG ng fuel minus 131.5. But take note na yung SG na to na makukuha natin using degree API is based on the standard temperature of a diesel fuel which is at 15.6 degrees Celsius or at 60 degree Fahrenheit. Alright? So, ibig sabihin na lang, yung makukuha natin ditong SG is at a different temperature pa. So, kailangan natin siyang i-correct pa base dun sa specific ng temperature na 45 degrees Celsius. So, first, kuhanin natin yung SG at standard temperature. So, we have degree API of 28 equal nga yan sa 141.5 over SG on standard temperature minus 131.5. So, SG on standard temperature of diesel fuel. So, compute natin. 141.5 divided by 28 plus 121.5. Ayan. So, diniretso ko na sa ating calculator para sa ganun ay SG na agad ang ating makukuha. Okay? So, 141.5 over yung degree API plus 131.5. So, kapag ganito yung ating ginawa, direkta na natin makukuha is yung SG at standard temperature. That is equal sa 0.887. So, i-correct pa nga natin ito or i-adjust pa nga natin ito base dun sa specific na temperature sa ating problem. So, according sa problem na yan, ang diesel fuel na gagamitin is at 45 degrees Celsius. So, ang gagawin lang natin dyan, yung SG at standard temperature which is 0.887, multiply lang natin sa correction factor na 1 minus 0.0007 for SI unit times change of temperature between the given temperature 45 and the standard temperature na 15.6. Ayan. So, SG at the given temperature of 45 degrees Celsius. Compute ulit natin. So, ito na yung ating standard. Nasa calculator na natin. So, multiply na lang natin siya to 1 minus the correction factor 0007 times change of temperature 45 minus 15.6. So, that is 0.869. Okay, so that is 0.869. So the specific gravity based on standard or based on 45 degrees Celsius na temperature is 0.869. So as you can see, that is different from the standard since nagkaroon nga ng adjustment or correction based on its specific na temperature. So for the density of that fuel, that is equal sa 0.869 na SG ng fuel times ang density ng water is 1 kilogram per liter at the same temperature. So we can say that the density of this fuel at 45 degrees Celsius is the same numerically as 0.869 kilogram per liter. Okay, so ganun lang yun. SG natin, minultiply lang natin to the density of water. Again, the density of water is 1 kilogram per liter on standard condition na pasok yung 45 degree Celsius temperature. The next problem. So actually, itong next problem natin hanggang problem number 37 yata ay continuation ng problem na ito. Okay? So yung nakuha natin dito ay number 34, magagamit natin yan hanggang dito kay number 37. So for number 37, so same given, ganun pa rin. Ang hinahanap is the fuel consumption in liters per hour. So in liters per hour, ibig sabihin that is volume flow rate naman. So makukuha naman natin si volume flow rate galing pa rin dun sa density. Kasi in general form, ang density is mass per unit volume. So kung kukuhanin natin si volume, that will be mass flow rate ng fuel over the density ng fuel. So yung density ng fuel na gagamitin natin, yung nakuha natin kanina kay number 34. So kailangan lang magkaroon tayo ng mass flow rate. So meron tayo ditong fuel consumption per power produced. So dito natin kuhanin yung mass flow rate niya. Okay, so mass flow rate natin dito, ganito ulit ha. Kung gagamitin natin is yung 0.56, i-correct na agad natin. Kung gagamitin natin yung 0.56 na given sa ating problem, so hindi natin makukuha yung tamang sagot na 220.5. Okay? Again, merong typographical error sa ating problem na to that we should be aware on troubleshooting. Okay? Kasi in this problem, instead na 0.56, this should be 0.65. And for the rest of the problem hanggang 37, ganun dapat ang ating magiging given dyan. Okay, so again, typographical error. So this should be 0.65. So please be aware on troubleshooting. Kapag again hindi makita sa choices ang tamang sagot, so pwedeng yung iba-ibahin yung mga choices para sa ganun ay, or pwede nyo iba-ibahin yung mga given para mapalabas nyo ng sakto ang tamang sagot sa choices. Or, pwede nyo gawin is back solve. Okay? Back solve. Kuha ng sagot from the choices, tapos tingnan kung ano yung magiging given na sasakto doon sa nako-compute natin. Alright? So, ganun. Back solving. That is another way of troubleshooting. So, ayun. So, gawin natin siyang 0.65 pounds per brake horsepower hour. So, mumultiply lang natin siya into that given brake power which is 650 brake horsepower. So, para ma-cancel out siya at makuha natin mismo ang mass flow. Since ang ating kailangang volume is in liters per hour, naka-SI unit, so kailangan ko itong i-convert into kilograms. So by conversion, ang 1 kilogram mass is equivalent sa 2.205 pound mass. So cancel out at magiging kilogram mass per hour. So compute natin. Again, that is 0.65 times 650 times the conversion of 1 over 2.205 ay 2.205. Ayun, that is 191.61 kilograms per hour. 191.61 kilograms per. Then, to get the volume flow rate or the fuel consumption, so substitute natin dun sa ating working equation. So, the mass flow rate is 191.61 kilograms per hour. At ang ating density of the fuel from problem number 34, 0.869 kilograms per liter. So, cancel out ang kilograms and volume flow rate of this fuel will be in liters per hour. So, divide na lang natin 191.61 divided by 0.869. So, that is 220.49 or approximately 220.5. Ayan. So, again, kung gagamitin natin is yung sadyang nakalagay dito sa ating problem na 0.56, so hindi natin mapapalabas na ganito ang tamang sagot. Pero kung ito troubleshoot natin at gagawin natin siyang 0.65, so sakto sa choices, 225 liters per hour. Okay, the next one, number 36. Again, continuation pa rin ng ating problem na to. Itaas lang natin para makita natin. Ayan, sige. Again, gawin pa rin natin itong 0.65 instead of 56. So, dito naman ang hinahanap natin ay minimum volume of the required day tank. So, kumbaga ay volume flow rate pa rin. Yun nga lang, this should be in per day na. Okay? So, kumbaga ito, conversion na lamang. Mula din sa na-compute natin at problem number 35, that is 220.5 liters per hour, ko-convert na lang natin sa 2 liters per day. Okay? So, we all know naman that for every for every 1 day, that is equivalent sa 24 hours. Cancel this out. At ang ating magiging volume per day, so multiply na lang natin sa 24, that is 5291.88. 5291.88 liters per day, or that is approximately 5292 liters per day. Okay, so ganun lang yon, conversion lang from liters per hour to liters per day. Next item, so for problem number 36, again, iangat lang ulit natin. At ganun ulit, instead of 0.56, this should be 0.65. But for problem number 37, so ang hinahanap naman natin ay cost of fuel per day. So dito meron na tayong given na cost, that is 7.95 per liter. So, ang gagawin na lang natin para makuha natin yung per day, so multiply na lang natin yung cost na given kay problem dun sa volume flow rate na nakuha natin kay problem number 36. Okay, so kumbaga nga continuous yung ating ginawa from problem number 34 kanina hanggang dito kay number 37. So yung cost na given is 7.95 per liter. So multiply na lang natin ito dun sa 5291.88 liters per day na volume flow rate. So cancel out yung liters at makukuha natin cost is per day. So yung nasa calculator natin, multiply na lang natin sa 7.95. So that is 42,070.41. 42,000. So malapit pa rin naman to 42,071 pesos. So 42,070.41 or 42,071 pesos. Okay? So, ganun lang yung ating problem na to. So, continuation lang, basic lang from the properties of diesel fuel. So, let us proceed naman dito sa problem number 38. So, ito ay ibang problem naman, pero about diesel engine. Okay, so let me read. A 2,000 kilowatt diesel engine unit uses 1 British barrel of oil per 525 kilowatt hour produced. Oil is at 25-degree API. Efficiency of generator is 93% and mechanical efficiency of engine is 80%. What is the thermal efficiency of the engine based on indicated power? So dito ang hinahanap is thermal efficiency on indicated power. Okay? So, nilagyan natin ng subscript na I to specify na yung thermal efficiency nga na ating kukuhanin is based on indicated power. So, ang thermal efficiency is ganun pa rin. That is work net output over heat input. Dito nga lang, since naka-specific yung ating magiging basis ng ating thermal efficiency, so gagamitin natin work net output is the indicated power. Okay? The indicated power over the heat input, wherein saan ba nang gagaling yung heat na i-input kay diesel engine? That will came from the diesel fuel or from the oil fuel. Okay? So for this thermal efficiency based on indicated power, that is equal lang to the indicated output power over the heat generated from the fuel. So kuhanin muna natin is yung heat indicated or heat generated by the fuel. This will be equal sa mass flow rate ng fuel na ginamit sa engine na to times yung kanyang higher heating value. So, ano bang pwede natin unang gawin? So, kuhanin muna natin is yung kanyang higher heating value. So, para sa pagkuha ng higher heating value ng mga oil fuel or ng mga liquid fuel, gamit yung kanyang degree API kasi yun yung property na given sa kanya. We have that formula in SI unit as equal sa 41130 plus 139.6 degree API. Ayan. Okay? So, may formula tayo ng ganito ng pagkuha ng higher heating value. So, kung isa-substitute natin yan, direkta na lang natin kay calculator. That will be 41130 plus 139.6 degree API na 25. That is 44,620. 44,620 again in kilojoules per kilograms. So, okay na tayo to higher heating value. Para naman sa mass flow rate ng fuel, so makukuha natin yan from the property ng fuel which is the density at saka volume flow rate. So, again, from the density na mass over volume, ang mass flow rate ay equal sa density ng fuel times the volume flow rate ng fuel. So, para sa pagkuha natin ng density ng fuel, so kailangan meron tayong specific gravity ng fuel. Again, manggagaling yan dito kay degree API. So, that will be equal sa 141.5 over 131.5 plus the degree API. Sinimplify ko na lang ha para makuha agad natin yung SG na agad. Okay? Nanggaling lang din ito sa formula ng degree API na 141.5 over SG minus 131.5. So, minanipulate ko na lang yung formula para direkta na natin makuha ang SG ng fuel. So, SG is 141.5 over 131.5 plus 20. Patuloy na lang natin to 3 decimal places, that is 0.904. So, as you can see, yung ating problem na to, wala namang specific na temperature yung oil fuel na ginamit. That is why, i-consider natin that this oil fuel is at its standard temperature na 15.6. So, hindi na natin siya kailangang i-adjust pa or i-correct pa yung value. Okay? Unlike dun sa ginawa natin kanina. Kasi again dito, wala namang specific na temperature yung oil fuel. So, i-consider lang natin that this oil fuel is at standard temperature. So, magiging density natin for this fuel, multiply lang natin to 1 kilogram per liter para sa density ng water. So, density of this oil fuel is also 0.904 in kilograms per liter. Okay? Then, para naman sa kanyang volume flow rate, so meron tayo ditong given na volume flow rate na niya actually. Okay? Yun yung 1 British barrel of oil per hour. So, i-convert lang natin siya to SI in liters per hour. Okay? So, by conversion, ang 1 British barrel is equivalent to 42 gallons. At ang 1 gallon is equivalent naman sa 3.785 liters. So, cancel out yung gallons, cancel out yung British barrel, makukuha natin to in liters per hour. So, 1 times 42 times 3.785. That is 158.97. Oops. In liters per hour. Ayan. Then, to get the mass flow rate ng fuel, so this will be density niya na 0.904 kilograms per liter times sa kanyang volume flow rate na 158.97 liters per hour. So, cancel out yung liters. So, this will be in kilograms per hour. So, multiply na lang natin yung nasa calculator natin na 158.97 sa 0.904. That will be 143.709. 143.709 kilograms per hour. Ayun. So, meron na tayong HHV, meron na rin tayong mass flow rate ng fuel. So, ang kailangan na lang nating makuha is yung kanyang indicated power para may substitute natin dito sa thermal efficiency. So, para sa indicated power, so meron tayo ditong given na so, meron tayo ditong given na generated power of this engine. Okay, so yun yung 525 kilowatts. Yun yung napoproduce ng buong engine na ito. So yung 525 kilowatts na output power ng buong diesel engine generator assembly, so divide lang natin siya to generator efficiency na 0.93 at saka yung mechanical efficiency na 0.8. Okay? Para ma-convert natin siya in terms ng indicated power. So, solve 525 over 0.93 times 0.8. So, that is equal lang sa 705.645 kilowatts. Okay. And then, ayan. So, meron na tayo. Kasya pa ba? Kasya pa. Sulat na lang natin dito yung tamang set. So, substitute na lang natin yan mula dun sa ating working equation ng thermal efficiency para ma-solve natin yung ating hinahan. So, the indicated power is 705.645 over QF na equal sa mass flow rate ng fuel which is 143.709 times the higher heating value na 44,620. Ay, ay naka-kilograms per hour yung ating mass flow rate. So, i-divide ko lang yung mass flow rate natin sa 3,600 para naka-per second. Para kapareho dun sa indicated power. Ayan. Okay? So, that will be 39 point, multiply lang natin ng 100. So, 39.62 or 39.6%. Okay? So, 39.62%. So, yan yung thermal efficiency based on the indicated power, which is tama naman at letter B. So, kung sakali kasi na ang ating hinahanap na thermal efficiency is based on the generated power, so yung 525 na ang ating magiging output. Pero kung ang hinahanap naman natin dyan is based on brake power, so i-divide lang natin siya sa efficiency ng generator. Yun na yung brake power natin. At kung ganito nga na ang ating thermal efficiency is based on indicated power, so yung ating generated power output is dinivide natin ang generator efficiency also with mechanical efficiency. Okay? Para ang makuha natin ay indicated power. Then, kung ano mang magiging basehan natin for this thermal efficiency, based on generated power man yan, or based on brake power, or based on indicated power, ang ating heat input palagi is based on the heat generated by the fuel, which is equal sa mass ng fuel times its higher heating effect. So, please be reminded na lang palagi dun sa mga formulas para sa iba't ibang properties ng fuel. Okay? So, that is about diesel power plant. Next naman natin for this refresher course is yung about naman sa mga steam power plant, steam engines, steam turbines, and other steam producing systems. Okay? Or steam generating systems. Okay, so dito hindi naman tayo gagamit na ng steam table kasi yung ating mga properties na kailangan is provided naman na sa ating problem. So let me read the problem number 39. An adiabatic turbine steam generating plant receives steam at a pressure of 7 megapascal and 550 degrees Celsius, where its enthalpy is given na nga kay problem, and exhaust at a condenser pressure of 20 kilopascal where enthalpy is also given. The turbine inlet is 3 meters higher than the turbine exit. Inlet steam velocity is 15 meter per second and exit is 300 meter per second. Calculate the turbine work in kilojoules per kilowatt. Ayun, so drawing natin si steam turbine. So, ito si steam turbine. So, let us say ito yung entrance at point 1 at ito yung exit at point 2. So, dito sa entrance niya, meron siyang given na enthalpy, meron siyang given elevation, meron siyang given velocity. Dito sa exit naman ng steam turbine, ganun din. Meron din given na enthalpy, elevation, at saka velocity. Okay? So, ang hinahanap natin dito is the turbine work per unit mass in kilojoules per kilogram. So, basically, ang gagawin natin dito is by energy balance lang. So, before, ang ginagawa natin para sa turbine work is equal lang palagi sa change of enthalpy. Okay? Ang ginagawa natin para sa analysis ng mga turbines or for any components using steam ay in terms lang palagi ng change of enthalpy. Kasi doon, lagi nating kino-consider, lagi nating ina-assume na neglected yung change of potential at saka change of kinetic energy. Kasi walang given at saka walang given na ang potential at saka kinetic energy. Pero dito kasi, merong given na elevation at saka merong given na velocity. So, hindi natin sila pwedeng i-neglect na lang. Okay? That is why yung work ng turbine na ito ay hindi lang basta in terms ng change of enthalpy. So, meron siyang kasamang change of potential and change of kinetic energies due to the elevation na given at saka velocity. Okay? So, ganun na. Kapag halimbawang wala namang given ng dalawa na elevation at saka velocity, so pwede natin silang i-neglect. Pero kapag given, kagaya sa problem na to, so isasama lang natin siya dun sa change of enthalpy. Okay? So, substitute na lang natin para makuha agad natin yung work output ng turbine. So, take note, pag tayo is kumukuha or pag tayo is ina-apply natin yung change dito para makuha natin yung turbine work, so palagi natin ginagawa is yung mas malaki minus mas maliit. Okay? Mas malaking value minus mas maliit na value. So, not the final minus initial kasi dapat absolute value ang makukuha natin turbine. Okay, so apply natin yun, substitute natin. So, for delta H, that should be H1 minus H2. H1 is 3531 minus ang H2 ay 2290. Kapag naman nag-energy balance kayo dyan, ganun din yung mangyayari dyan. Okay? Not the final minus initial, but the mas malaki minus mas maliit na value. Kagaya nito, H1 minus H2 in kilojoules per kilogram. So, para naman sa change of potential energy, tandaan na ang potential energy is mgz, mass times gravitational acceleration times elevation. Wala nga tayo ditong mass kasi naka per unit mass tayo. So, gz na lang. Okay? That is the gravitational acceleration na 9.81 meter per second square times the change of elevation. So, dito, sabi sa problem, ang inlet daw is 3 meters higher than the exit. So, kung ang ating reference sa level is nasa exit, so ang magiging elevation 1 is 3 at ang elevation 2 ay 0. Okay? Kasi nga, ang ating reference ay nasa exit. Okay? Since nandoon sa exit ang reference, therefore, wala siyang elevation. So, kaya dito, ang gagawin lang natin ay yung elevation 1 na 3 meters. Then, dito, ang magiging unit natin dito ay hindi pa nakakilo. So, katulad na lang ng ginagawa ko palagi sa kinetic energy. So, dinidivide ko na agad to ng 1,000. Okay? Yan, lumabas. Yan. So, dinidivide ko agad to ng 1,000 para ito is maging nakakilo na agad. I-analyze ko lang yung unit dito dito sa side na to. Kasi kung inyong mapapansin, this will be in meter per second square times meter. From Newton second law nga, ang equivalent nga ng Newton ay equal sa kilogram times meter per second square. So kung kukuhanin natin yung value ng meter per second square, that will be equal sa Newton per kilograms. Okay? So kumbaga, itong meter per second square na to is magiging Newton per kilogram. E ano ba ang Newton times meter? Diba ang Newton times meter ay joules. Okay? Ang Newton times meter ay joules. So, ang magiging unit nito ay joule per kilogram. So, dinidivide ko agad ng 1,000 para siya is maging kilojoules. At kapareho nung change of enthalpy kanina. Alright? Plus, para naman dito sa change of kinetic energy, so 1/2 mv squared. So, wala nga tayong mass, kaya velocity na lang. So, velocity 1 is 15 squared minus velocity 2 is 300 squared. Again, instead of 1/2, ang ginagawa ko na nga dito, katulad dun sa potential energy, ginagawa ko na siyang 1/2000. Okay, so dinidivide ko na rin sa 1,000. Bakit? Para nga, ang unit niya is maging kilojoules per kilogram na din agad. Okay? Ayan, para maging kilo na agad ang unit natin dito. Okay? Ayan. Then, calculate lang natin at makuha natin ang work ng turbine in kilojoules per kilogram. 3531 minus 2290 plus 9.81 times 3 over 1,000 plus squared minus 300 squared over 2,000. Yun. So that is 1196.14 in kilojoules per kilogram. Hindi man saktong-sakto sa ating choices, pero isang digit lang naman ang naiba. Okay? So yun pa rin naman ang katulad dito sa ating choices na to. So letter B, 1196.24 or 1196.14 kilojoules per kilogram. So dito ay application pa rin ng first law of thermodynamics ang ating ina-apply. Okay? So kung meron ditong mass, i-multiply mo na lang dyan. Okay? Kasi yung mass naman na yon ay applicable sa lahat ng energies na ito. Ngayon, so that is for problem number 13. Proceed tayo. Dito ay problem number 40. So, okay na yan. Doon natin ibaba. So, a 2 kg steam at 2.5 megapascal absolute and 260 degrees Celsius undergoes a constant pressure until the quality becomes 70%. Determine the heat rejected in BTU. Given na nga ang mga properties. At 2.5 megapascal absolute and 260 degrees Celsius, enthalpy is given na. And at 2.5 megapascal and 70% quality, given ang HF at saka HG. Okay? So, ang hinahanap ay yung amount ng heat rejected lang. Tapos, binanggit sa ating problem na at constant pressure na. So, from thermodynamics pa rin, application pa rin from thermodynamics, at constant pressure, ang amount ng heat, by addition man yan or by rejection, ay laging equal sa change of enthalpy. H2 minus H1. Then, multiply na lang natin sa mass or mass flow rate. Depende kung anong given. Okay? So, ganun lang din. Ganun lang din yung ating formula for this one. So, meron namang given na mass at yung mga enthalpies naman natin dito ay given na din sa ating problem. So, yung ating enthalpy 1 is yung initial na condition ng ating problem. Ang initial condition daw na nga ng ating problem or ng steam sa ating problem is at 2.5 megapascal and 260 degrees Celsius. And as you can see, yung enthalpy at that condition is given na. Yun na yung 2907.4. Okay? Yun na yun as is na. Kasi given na nga sa ating problem. So, kailangan na lang natin kuhanin yung para sa enthalpy 2. Kasi kung inyo mapapansin, after the constant pressure process nga nung steam, naging ang quality daw is 70% na lamang. So, bumaba na. So, nahaluan na ito ng moisture content or ng liquid. So, kumbaga, ito is naging wet mixture na. Diba, meron tayong formula ng pagkuha ng enthalpy of wet mixture. So, that is equal lang sa HF plus X times HFG. Na again, ang HFG ay equal sa HG minus HF. So, at 2.5 megapascal, so given naman yung mga properties na yon at given naman yung quality na X, so makocompute natin ang enthalpy 2. So, HF is 962.11 plus 70% or 0.70 na quality times ang HFG nga is HG na 2803.1 minus HF na 962.11. Okay, so calculate natin. 962.11 plus 0.7 times 2803.1 minus 962.11. So, 2250.803. 2250.803 in kilojoules per kilograms. So, ayun, meron na tayong mga enthalpies. So, makukuha na natin yung amount ng heat rejected. So, substitute lang. Ang mass natin dito is 2 kilograms times ang H2 natin. Gawin uli natin is pagbalik na rin natin yung enthalpies para maging absolute value yung ating mako-compute. So, okay lang kahit balik na rin kasi naka-absolute value naman yung mga choices natin. So, kahit hindi na natin siya palabasin, naka-negative kasi alam naman natin na rejection yung process ng heat transfer. So, gawin na lang natin siyang H1 minus H2. H1 is 2907.4 minus H2 ay 2250.803. Again, ito ay naka-kilojoules per kilograms. So, cancel out yung kilograms. Ito ay magiging kilojoules. Ang hinahanap naka-BTU. So, conversion na lamang. By conversion, ang 1 BTU is equivalent sa 1.055 kilojoules. So, cancel this out at makukuha natin yung heat rejected in BTU. So, 2907.4 minus 2250.803 times 2. Okay, divided by 1.055. That is 1244.7. Ayan, saktong-sakto na, nasa choices na yan. 1244.7 BTU. So, ganun lang. Okay? So, ang heat, yung amount ng heat at constant pressure is equal lang sa change of enthalpy. So, given naman yung enthalpy na, kaya yun ang ating ginamit. Lagi ba na ang heat, rejection man or addition is equal sa change of enthalpy? Hindi. Equal lang yan sa change of enthalpy kapag constant pressure. Kapag yan is at constant volume na, yung heat, rejected man or added, is equal na sa change of internal energy naman or delta U. Okay? So, dito lang, yung heat natin is equal sa change of enthalpy kasi constant pressure process. Alright? So, those are the problems involving steam cycles naman. Okay? So, let us proceed. Ayan, so damihan pa natin since medyo maunti pa naman yung time. So, let us proceed naman with hydroelectric power plants naman. So, dito naman sa number 41 hanggang 43. Okay, so dito naman tayo kay 41. So, let me read. A mini hydropower plant has an available head of 5 meters. If the water flow is 1.25 cubic meter per second, efficiency of the turbine is 90% and efficiency of the generator is 92%. Determine the maximum output of the generator in kilowatts. Ayun, so ang hinahanap is the output of the generator, output power of the generator. Well, of course, makukuha lang natin siya from the generator efficiency. Okay? Ang generator efficiency, output over input. Of course, yung output niya, yung hinahanap natin. Yun yung generator power output. While yung input naman natin dito is nanggaling mula din sa brake power output ng turbine naman. So, yung brake output power naman ng turbine, makukuha naman natin siya from its efficiency. Ang efficiency naman ng turbine, output over input. Ang output nga natin dyan is the brake power at ang input natin is the ideal work of the turbine. Alright? Okay. So, ayun. So, bakit natin kinonsider ito? Kasi may mga given na efficiencies. Kung walang given na generator efficiency, so ibig sabihin, equal lang yung generator power sa brake power. Okay? Or, kung wala namang given na turbine efficiency, so equal lang din yung brake power sa ideal work ng turbine. Okay? So, para ma-simplify natin, since ang hinahanap naman natin is yung output ng generator, so yung brake power ay kuhanin ko dito from the turbine efficiency. So yung brake power is equal lang sa cross multiply lang ito. That will be the ideal work of the turbine times its efficiency. At kung isa-substitute natin dito sa generator efficiency, that will be equal sa generator output power over Again, ang brake power is yung ideal work ng turbine times the turbine efficiency. Therefore, yung ating hinahanap na generator output power, cross-multiply lang uli, that will be equal lang sa ideal work output ng turbine times turbine efficiency times generator efficiency. So, kumbaga, yung ating magiging pinaka-output dito is yung ideal times yung lahat ng efficiencies. Okay? Tandaan, nagkataon lang sa ating problem na dalawa yung given efficiency. So, kung isa lang yan, so isa lang ang i-multiply. Pero kung dalawa, kagaya nito, so pareho mo silang i-consider. At di ba yung pagkuha natin ng ideal work ng turbine ay equal lang sa Q gamma H. Okay? So, diretso na natin, substitute na natin para makuha na natin ang generator output power. Again, ang ideal work ng turbine ay equal sa Q gamma H. Ang Q or yung volume flow rate ng water is 1.25 cubic meter per second. Ang gamma ng water is 9.81 kilonewtons per cubic meter. At ang height is 5 meters. Again, ito ay Q gamma H para sa work output ng turbine. Multiply natin to turbine efficiency na 90% at generator efficiency na 92%. So, cancel out ang cubic meter. Kilonewton meter is kilojoule and kilojoule per second is kilowatts. Ayan, as you can see, multiplication lang lahat. I-multiply mo lang kumbaga yung lahat ng given. Well, of course, kasama itong G. Okay? Although hindi yun given, pero dapat meron laging G kasi kasama yun sa formula ng nung gamma pala, sorry, nung gamma. Kasi kasama yun sa formula ng work ng turbine. Ayun, so that is 50.77 kilowatts. So, 50.77 kilowatts. So, napaka-basic lang. Work ng turbine for hydraulic turbine is Q gamma H. Then, multiply mo na lang ng mga efficiencies kung ano yung mga efficiencies na given para dun sa mismong hinahanap. Okay? Next tayo, number 42. If it is desired to use a type of hydraulic turbine whose specific speed is 50 RPM to deliver 150 horsepower at 150 feet head, what will be the corrected speed of the unit? So, dito ang hinahanap, ano daw yung corrected speed niya? Kung ang magiging specific speed is 50 RPM based dun sa specific type ng hydraulic turbine na gagamitin. So, meron tayong formula ng specific speed ng hydraulic turbine in English unit. That is equal lang sa N square root of the brake horsepower divided by the head in feet raised to 5/4. So, yung hinahanap nating corrected speed, ito yung N na ito. So, para madali natin makalculate, so i-manipulate lang natin siya, cross multiply, para diretso ng N ang ating makukuha. So, yung specific speed nating NS, i-cross multiply lang natin itong H raised to 5/4. Tapos, i-divide lang natin yung square root ng brake horsepower. Para diretso, ang makukuha natin is yung corrected speed. So, the specific speed is 50. Tandaan na yung head dito dapat naka-fit. So, tama naman yung given natin. So, wala nang conversion na gagawin. 150 feet raised to 5/4. Square root of yung brake power natin dito dapat naka-horsepower din. So, naka-horsepower na naman yung given sa ating problem. So, wala na rin tayong dapat na i-convert. So, diretso sa calculator, that will be 50 times 150 raised to 5/4. All over square root ng 150. That is 2,143. Okay, 2,143 RPM. Ayun. Okay, so ganun lang yun kasi. Next tayo. So, last item for this part. Last lang natin. Ayan, number 43. Ayan, so let me read. In Maria Cristina Hydroelectric Project, the available head is 140 meters. The water flow is 1 cubic meter per second. Efficiency of the turbine is 95%. And efficiency of the generator is 95%. Three phases, 60 cycles. Voltage delivered is 4160 volts. Determine the estimated yearly output of the generator. So kung inyong mapapansin, this is just the same dun sa ating problem kanina na hinahanap is the generator output power. Ganun lang din yun. Okay, ganun lang din ito. Okay, so dito lang ang hinahanap is per year na generator output power. Okay? So mula din sa ating ginawa kanina, ang generator output power ay equal lang sa ideal work ng turbine times the turbine efficiency times the generator efficiency. Na again, ang ideal work ng hydraulic turbine ay equal lang sa Q gamma H. So Q gamma H ng turbine times the turbine efficiency times the generator efficiency. Tapos, magkakaroon na lang tayo ng conversion para ang makuha natin is on yearly basis. Okay? So, substitute. Ang Q natin dito is 1 cubic meter per second. Ang gamma pa rin natin is gamma ng water, that is 9.81 kilonewtons per cubic meter. At yung head is 140 meters. Multiply lang natin to turbine efficiency 0.95 at saka sa generator efficiency 0.95 din. So cancel out lang yung cubic meter. Ayan. So kilonewton meter is kilojoule, kilojoule per second is kilowatts. So ito is magiging kilowatts. Okay? So, gagawin lang natin siya energy in yearly basis. So, mumultiply lang natin siya to the number of hours in yearly basis. Kagaya ng ating na-discuss dun sa variable loads, tatandaan natin that for every 1 year, ang katumbas niyan ay 8,760 hours. Okay? Kompleto, walang labis, walang kulang. Let us assume na yung hydroelectric power plant na to ay 24/7 sa buong taon nag-ooperate. Okay? Ayun. So, kaya yung buong number of hours for 1 year ang ating pinansin. Okay? So, substitute or calculate lang natin. Q is 1, gamma is 9.81, H is 140 times efficiency. Okay? Then multiply nga lang natin to 8,760. So that is 10,857,963.06. 10,857,963.06. Ang magiging unit nito will be kilowatt hour per year. Okay? So, kagaya ng nakalagay dito kay letter B. So, ito yung naging yearly na generated output energy ng hydroelectric project na ito. Okay? So, again, that is for part 4 nitong ating discussion na to. That is for the rest of the power plants. So, we have one last part para dito sa ating continuation ng pipe refresher natin for the remaining items na ating i-discuss. So, watch out for that part 4, okay, or for that last part para dun sa mga last items na ating i-discuss. Thank you guys!